So hello guys, welcome back to my YouTube channel hansda Education. So in this video I am going to discuss about the basic approach to solve SHM questions. Okay. So here it is the steps. So first of all you have to identify the equilibrium position of the body performing SHM. Okay. So this is our first task. We have to find out we have to identify the equilibrium position. Okay. Equilibrium position of the body which is performing SHM. Okay, this is our first task. We have to identify its equilibrium position. Okay, and then we have to write down all the equilibrium equations in this position. Okay, in step number 2 we have to write down all the equilibrium equations. Okay, in this position. Okay, and these equations are to be used later. Okay, so in first step we have to find out the equilibrium position, then we have to write down all the equilibrium equations in this position. Okay, and now what we have to do, we have to displace the body from its equilibrium position. Okay, through a small displacement delta x. Okay, this is the third step. We have to displace the body from its equilibrium position through a small displacement delta x. Okay, and now we have to write down net force over the body in this displaced position. Okay, we have to write down net force, okay, over the body in this displaced position. Okay, and we have to bring this equation into this form. Okay, f naught equal to some minus k times delta x, where k is a positive constant. Okay, so you have to bring the equations in this format. Okay, then you have to put this k equals to m times of omega square. From this we can calculate omega and time, frequency, etc. Okay, so this is the basic approach. So I am just repeating it again. Okay, so first of all you have to identify the equilibrium position of the body which is performing SHM. Okay, this is the task number 1. Then you have to write down all the equilibrium equations in this displaced position. Okay, and these equilibrium equations are to be used later. Okay, now we have to give a small displacement to the body from its equilibrium position. Let's say the small displacement is delta x. Okay, now we have to write down the net force over this body in this displaced position. Okay, then you have to bring this net force in this format. It is f naught equal to minus k, where k is a positive constant, time delta x. Okay, then you have to just put this k equal to m times omega square. From this we can calculate omega and time, frequency, etc. Okay, so let's see an example to find out the time period of a spring block system. Okay, let's say the mass of this block is m and the spring has a spring constant of k. Okay, now our first task is to find out the equilibrium position of this block. Okay, at the equilibrium position this body will be displaced downward direction. Okay, and the spring will be elongated. Okay, the picture at equilibrium position will be something like this. Okay, let's say this body has displaced through an amount delta naught from its natural position. Okay, so in this position a vertical force mg will act downward direction and a spring force of kx will act in kx naught in will act in upward direction. Okay, at equilibrium we can say that kx naught equal to mg. Okay, this is the equilibrium equation and we have to keep in mind this, and we have to use this equation later. Okay. Now what we have to do? We have to displace this body from its equilibrium position through a small distance delta x. Okay. So further I have to displace this body. Okay. Then it will be something like this. Okay. This was initially elongated through a length of x naught, and further I give a displacement of delta x. Okay. Now the total elongation in this spring will be x plus delta x. So a upward force of k into delta x will act in the upward direction, and mg is constant, it will act in vertically downward direction. So our next task is we have to find out the net force over this body in this displaced position. Okay. So that net force will be k into x plus delta x, force is acting upward direction, and mg is downward. So net will be k into, sorry, it's x naught. So x naught plus delta x minus mg. So it will be k x naught plus k time delta x minus mg. So it will be, but we know that kx not equal to nothing but mg. So it will be mg plus k into delta x minus mg. So it will be k time of delta x. Okay, that is the f naught, and we have to just put this k to be m omega square. So omega will be k upon m whole root over. So from this we can find out the time period to be 2 pi into m upon k whole root over. Okay, this is the basic approach. Okay, to find out the time period. Okay, so thank you for watching this video.